Okay. So references. Okay, this is again some new stuff. So C++ references are a way of basically having an alias for an object. Okay. So we've still got an int I. Okay. Now we've got a reference R. Okay. So this ampersand is a reference. Okay. Works a bit like a pointer, but it's not a pointer. Okay. We can also have a constant int, so a constant reference to I. Okay. A reference like an alias. Okay. I keep having to stress that. Basically, everywhere you put I, you can now put R. Okay. You don't need to do the star. You don't need to do dereferencing. Okay. It must be initialized when defined. Okay. So you can't just have. Let me do a little code. You can't do this. Okay. Can we see that? Yep. So this is fine. Oops. No, it's not. Int I like that is fine. Okay. Int pointer. Oops. That is fine. Okay. Int. That is not fine. That will not compile. Okay. So again, separating out this declaration and definition things. Okay. That will compile fine, and I can do this. I equals 6 there, or 7. Okay. I can do this one. I can do int p is equal to the address of I. That's fine. This I cannot do. I cannot do this point here. Int r is equal to I. This won't work. Okay. This reference needs to be defined where it's declared. Okay. So that works. So if int reference, actually reference to I, needs to be declared up there. Okay. So by default, a reference is always const. Okay. What that means is if I say this, int j is equal to 8. Okay, so int j is equal to 8. If I say int r at this point is equal to j, okay, where that 7 is currently sitting in I, that will get updated to 8. Have I lost everyone? Okay, let's write this up as a program. Give me 20 seconds. Okay, so hash include IO stream. Okay, let's just create a main. Okay, int I is equal to 7. Int, oops, j is equal to 8. Okay. Okay, let's output I. Okay, so I print out I. Okay. Int r is equal to I. Okay. Equal to j. Now I'm going to print out I again, okay? That's I hope this works. Live demos, you've got the danger of going wrong. Reference, I can do things like this. Plus plus and r, and that's going to print out 9 now. It does there. Okay? So references work like standard ints and things work. Okay? So we've got these references, we've got the idea behind them. Okay, they're an alias for a type. Okay, they're not a type themselves. Okay? So they're different from pointers. Pointers are types. Okay? So a reference is always const, because when it's defined, it can't be modified later on. So it can modify what it's pointing to. Well, it's not really pointing, but you can reference what it's aliasing. Okay, but you can't change where it's looking at. Okay, and so it's not an object. And a reference to a const object is often said to be a const reference. Okay? And as you can expect, a reference to a non-const object is often said to be a non-const reference. You should ideally, not all the time, but you should ideally be using references rather than pointers. Okay? Because they're safer, because they can never be null. Okay? They always have to be pointing to something. And the reason why I've got my fingers like that is because they always have to be aliasing something. Okay? So a reference can never be null. Okay? But then we can get into this fun and games, up on the left-hand side again. So I can say int I is equal to 5. Int reference R is equal to I, okay? R is equal to 6, and C out I, and that's equal to 6 now. But if you look back to this left-hand side down here, if you say const int J, and then you say int reference to J, that's an error. Because that's const and that's not const. Okay, so the same const rules apply as earlier. Okay? And so then we have const references, okay? So you have int I equals 5. You then want a const int reference to I. Well, I is not const, so that's not going to work. Okay, so for references, the const needs to match. Okay, remember with the pointers, you had, oops, which one of these const is going where? Like, do I have star const or const star? Okay, very confusing. With references, the simple way you need to remember it is if your variable is const, then your reference needs to be const. If your variable is not const, then your reference doesn't need to be const. Okay, and it won't compile if you do it wrong. Okay, come down to this line 6 down here. Constant J is equal to 5. Const int reference here is equal to J, that's fine, but then you can't modify it because it's const, as you'd expect, so it behaves the same way. Okay? And you can do things like int I is I and the const long is a reference here, where you can't do that if it's a pointer. Okay, so we had this problem before about the pointers for a long can't reference an int. This can, because it can be casted up to it. Okay? But again, don't do that. It's dumb. Just use your common sense when doing these things. Okay? And also, you can't initialize something to be a literal. Okay? So you can't say a reference to the number 100, because that's not a variable. That's just a number 100 sitting in memory somewhere. Okay? So you can't do that. Oh, sorry, it can be. I'm telling you fibs. It can be. So a pointer can't do that. A reference can. Okay? But again, depending on what you're doing, that may or may not be good code. I would probably personally go, if you want to do that, just define it as a constant int rather than needing the reference there. Okay? Doesn't really make sense putting the reference there. Okay? So you can mix pointers and references. Okay? So int I is equal to 5. Pointer P, reference R, okay? You can say at R, your reference is equal to the address of I. The same thing as saying your pointer is equal to the address of I. Okay? So see how this here, this nasty, nasty thing here, this pointer ampersand R, is a pointer to a reference. Okay? And you can say star P is equal to 6. Again, unless you have to, don't do these things. Okay? It makes your code so difficult to read. Okay? So use your common sense when doing these things.